In order to solve a system of equations using substitution, you will need one of the variables in one of the equations to be isolated or solved for. If it is not, then you must solve for one of the variables in one of the equations. In our first example, our second equation, x is isolated or solved for, and it is equal to y plus 13. You'll notice that in the first equation we also have an x as well. So to solve using substitution, we're going to take y plus 13 and substitute it in for the x in the first equation. So when you plug it in, it's going to be 4 times y plus 13 plus 2y equals 10. In order to solve this, we must distribute the 4 to both terms. 4 times y is 4y. 4 times 13 is 52. Bring down plus 2y and 10. From there, combine like terms. 4y and 2y add up to 6y. Plus 52 equals 10. In order to solve for y from here, we're going to subtract 52 from both sides. This is now 0. So on this left side, all we have is 6y equals 10 minus 52 is negative 42. And our last step to solve for y is to divide both sides by 6. And y is going to be equal to negative 7. So our solution to our system, or the point at which these two lines cross, we have one of the coordinates, the y value, negative 7. In order to find the x, we must plug negative 7 in for y into one of the two equations. While it doesn't matter which one you choose, it's more efficient to choose the one equation that already has a variable solved for. So the second equation, x equals y plus 13, I'm going to plug in negative 7 for y. So x equals negative 7 plus 13. Negative 7 plus 13 is 6. So you have found your x coordinate of your solution. So these two points, these two values create or make up the point at which these two lines cross, or the solution to the system. Now, if you're unsure about your solution to the system, you can check the solution in both equations. Starting with the first equation, plug in 6 for x and negative 7 for y. If the left side is equal to 10, then you know you have, so far, this equation checks out. 4 times 6 is 24. 2 times negative 7 is negative 14. 24 minus 14 is 10. So this equation is okay. But it's not enough to just check one equation, you must check both. So let's check the bottom equation. Instead of x, I'm going to write 6. Instead of y, I'm going to write negative 7 plus 13. And as we just checked, negative 7 plus 13 is 6. So that checks out as well. So now I know for sure that 6, negative 7 is a solution to this system. As I mentioned earlier, in order to do substitution to solve a system, you must have one of the variables in one of the equations isolated. In the second example, you'll notice that in neither equation is any variable solved for or isolated. So you must choose one of the variables in one of the equations to solve for. Now, there are situations where it's more efficient to solve for one variable compared to another. In this case, you'll notice that the y in the first equation has a coefficient of 1. When you have that, it makes it much easier to solve for. So take the first equation and solve for y. And again, we are solving for y because the coefficient is 1. Now, this is optional. You can solve for any of them and still get the correct answer, but it's the least amount of steps when you choose the coefficient of 1. So to solve for y, we're going to add 4x to both sides. Y equals 4x minus 20. And we have solved for y successfully. Now, y equals 4x minus 20. So the second equation, there is a y variable. So we're going to take 4x minus 20 and plug in for y into the second equation, and then solve for x. Just want to use some highlighters to show you exactly what I am doing. So I'm going to rewrite that second equation, negative 2x minus 2, but instead of writing y, I'm going to write 4x minus 20. The same method of solving we did for the first example is going to apply here. First distribute. Negative 2x, negative 2 times 4x is going to be negative 8x. Negative 2 times negative 20 is going to be positive 40. Equals 10. Combine your like terms. Negative 10x plus 40 equals 10. That makes, because negative 2x and negative 8x adds up to negative 10x. It's a two-step equation from here. Subtract 40 from both sides. Negative 10x equals negative 30. Final step, divide both sides by negative 10. X equals 3. So our solution to the system right now, we have an x value of 3. For every solution, remember, you need an x and a y value. So take the x value of 3 and plug it back into one of the equations. Now, the most efficient way of doing this is using the one that has y already solved for. So this equation right here. So here we're going to plug in 3 for x. So we're going to have y equals 4 times 3 minus 20. 4 times 3 is 12 minus 20. 12 minus 20 is negative 8. So we have found our y value of negative 8. Now if you're unsure about the solution, you can check for both equations. 3, negative 8. So the first one, negative 4 times 3 plus negative 8 equals negative 20. So you're going to have negative 12 when you multiply negative 4 times 3 minus 8 equals negative 20. And negative 12 minus 8 is negative 20. So that equation checks out. The second equation, negative 2x minus 2y equals 10. So negative 2 times 3 minus 2 times y, which is negative 8, equals 10. So you're going to have negative 6 when you multiply negative 2 times 3. You're going to have positive 16 when you do negative 2 times negative 8. And negative 6 plus 16 is going to be 10. So that equation also checks out. So my solution to the system is 3 comma negative 8. And remember, this really means that the two lines cross at this point or intersect here.